Okay, good morning class. So today we're looking at exponents or indices. At this point we have looked at the first rule of exponents, not so? And we started discussing the second rule of exponents, okay? So we said that if you got x to the exponent 5 over x to the exponent 3, we know that this can be written as x times x times x times x times x. There are 5 x's over x times x times x, which are 3 x's. We know that x over x's equal to 1. As y squared over y squared is 1. No? So the y squared goes into y squared once, and y squared goes into y squared once. Okay, so I got 8x squared y cubed over 8x squared y cubed, that is equal to 1. Okay, so as long as the numerator and the denominator is the same, it will give you an answer of 1. So of course x cancels x, x cancels x, x cancels x, which then in turn leaves me with x times x, which is x squared. Not so? Then we said that if we look at x to the exponent 5 over x to the exponent 3, and we have to now use a mathematical rule. What do you notice here? That 3 minus 5 is 2. Can you see that, people? 3 minus 5 is 2. So here, sorry, 5 minus 3 is 2. So if you add x to the 80 over x to the 20, I'm not going to write x multiplied by x 80 times. You understand? So we use the mathematical rule, which is x to the exponent 80 minus 20, which is x to the exponent 60. So the rule says when dividing terms with the same basis, we subtract the indices or the exponents, and that's the note we made. Not so? Okay, and then we had written the mathematical ruling there, and we're going to put it in the box there. Right, you understand? Right. You still with us, people? Did you do the examples? You look at the first example here. The example's on page 30. Okay. So here we got 2 to the exponent 5 over 2 squared. So when we're dividing and bases are the same. Are the bases the same? Yes. What is the value of the base here? 2. Not so. When we're dividing and bases are the same, we subtract the exponent. So it's 2 to the exponent 5 minus 2. So that's 2 to the exponent 3. You can write 2 to the 3 is what? 2 to the 2 cubed. Yes. If I want to simplify it, what will it be? 2 times 2 times 2, which is 8. Okay, you guys understand? So look at the next one, number 2. Is the basis the same here? We've got x to the exponent 4 divided by x. Are the bases the same? Yes. Both are x's. What is the exponent of x in your denominator? 1. Can you see that, people? So that's going to be x 4 minus 1. Can you see that, people? X 4 minus 1, which is x cubed. You all understand? Let's look at the next one. Look at the next one. Number 3, so the examples on page 30. We are now given 6x cubed b to the 6 divided by 3ab to the power 4. So what do I do here? Again, we're going to simplify our number. You see the coefficients here? We'll simplify different, as we normally did when we did our BODMAS fractions. Not so? So 3 goes into 3 once, 3 goes into 6 once. So it's 2. I can write it as 2 over 1 if you like, okay? So it's 2. Normally we write below, no? So it will be a to the exponent 3 minus 1. B, 6 minus, which is simply 2a. 3 minus 2 is, 3 minus 1 is 2b squared. You all understand? You see any confusion? You all understand? Okay. Because the way I cut it, I would have to write 9 next to it again. But this is the layout that you normally follow. Okay? As in question 3. Let's look at question 4. We're moving to force. No, okay. The number 4. We look at the coefficients of the numerator and the denominator. Is there a number that can simplify into 3 and to 4 without remainder? No. Other than 1? No. So that remains 3 over 4. What is the exponent on x in the denominator? 1. So in other words, that's going to be x to the 5 minus 1? 1. Can you see that bases are the same? Can you see that? So only those exponents get subtracted. Does it make sense? Okay. So that would simply give us 3 over 4 x 4 y. It can be written like that, or it can be written as 3 over 4 x to the exponent 4y. Make a note there that it's the same. Okay. Is there any confusion there? Any questions? No? Let's look at number 5. Look at number 5. So looking at number 5, is there any number that can go into the numerator and the denominator there without a remainder? Which is 2x to the exponent 10y cubed z over 4xy squared z. We're saying yes, and what number goes into both without remainder? 2. So 2 goes into 2 once, 2 goes into 4 twice. So you see that the 2 is in the denominator. If the 2 was in the numerator, if it was 4 over 2, if the 2 was in the numerator, that could have been written as 2. Would be why? Because that's 2 over 1. However, if it's 2 over 4, it goes 1 and 2. So it's going to be okay, so don't get confused there. If it's in the denominator, I have to write the fraction. So it's 1 over 2. Okay. So you see the x is here. Only those exponents can be subtracted. You guys understand? Again, only those exponents can be subtracted and those exponents. But what is z over z? Z divided by z is going to be 1. Because x over x is 1, 2x squared over 2x squared is 1. So z over z is 1. Okay. What I'm going to do is, I'm going to put here, so we see that goes 1 and 2, the z's cancel. So we have x. X to the exponent what? 10 minus 1. Y. 3 minus 2. And the z cancel. Okay? Which in turn can be now written as 1x, what's 10 minus 1? 9. Y to the exponent? 1 over 2. So do I need to write this 1 here? Do I need to write it? No, you don't have to write it. So this can be written as, I'm saying, or, as we don't need to write that 1 on the exponent on the y either. If the x is written on its own, we know there's a 1 and there's a 1 there. There's a 1 as the coefficient and there's a 1 as the exponent or index. Okay. Will you guys understand? Okay. Okay. Alright, you guys understand, people? Alright. So this can be written as x to the exponent 9y over 2. There's another way that this can be written as.
Thank you, sir.
Pleasure. Another way it can be written as. It can be written as a half x 9y. So any one of those in the exam is going to get you the full mark. You guys understand? Okay. So please make the note of the variations on that solution there. Just look at number 6. People, in number 6 you've got 10p squared q squared over 10p squared q squared. Your numerator is exactly the same as your denominator. So what is that answer then going to be? 1. You all agree with that? 10p squared q squared goes into itself once, which is 1 over 1. Gives you an answer. Do you guys understand? Is there any questions? Any confusion? For that you should be able to do exercise 2 on page 30. At this point I'll stop the video.